another contract, putting on the different code. Okay, so method number 2 is we are using the parents. Okay, import the parents into the child and then use this code and call contract child is parent. Okay, what does this mean here? It means that over here we go, you should separate your contract. Maybe over here I created another file, new file called parent.so, different file already. One is the parent.so, another one is the child. Okay, child.so. So the parent still got parent code long, so we go and copy the parent code over there. From this side, I copy the parent code from here, the whole thing, dump it inside the parent. So the difference, I think that because compiler generated the bytecode at the back, okay, from here. So what we need to do here is, then we have a child, so we're going to copy the child, the whole thing, okay, the child only, child over here. We don't copy the caller, pass it back over this side. So then we go and look for this particular contract, this particular line over here. I do testing first, So then you can see that I just separated out the contract, parent contract and child contract into the different file, into the parent.so and the child.so. So from here, this is the parents. So, but for the child.so, you can see that they said that they cannot find. Okay, you cannot identify it. That this identifier not found. So then what we need to do, we need to go and use the import. Based on over here, we are using the method number 1. So if you are having a different, your parents is on a different file you're going to see that you can go and do import. Okay. And you can do import. Semicolon. Parent.so
capital,
uppercase, because I call parents, okay, not lowercase t. You see that? So this is a part for that. So you can be simply go and add in your, this one I deleted back. So you can simply go to have a, because already compile, I make your, because of auto compile, your artifact already generated. Your artifact already generated from here. Okay? Parents, okay, the parents. So the parent.so, the parent JSON file, okay? This one, parent, the child JSON file and also the parent JSON file is there already. So auto compile for that. So that's why from here what I need to do here is I can directly go and compile for the child. Okay, I directly compile for my child. You can see that. See, let me check whether I can move from the child or not. So I go and directly deport for my child contract from here. Can work or not? So I have a child contract here. So get value, set value can be directly get it. Alright? So you put it on a different file. Parents, I don't do anything now. I just deleted out only. Just for parents, just a child for an additional this line. This is a much more easy and faster way. This one, method, can I move on? Method number 2, this method number 2, you go and extract, create the extract contract interface in a parent contract used to import method. So parents, and create the instance of the extract contract in a child contract file instead of is parents. So this one is we don't use the is parents, but we wanted to put abstract contract interface. You will go and see some of the example in the online resources they're using the abstract contract interface. So how? So this one, anyone got problem for method number 1? If no, then I move on the method number 2. Okay, we don't use. Okay, we do not use is parents. We don't use this one. We do not use this is parents from here anymore. This one. We don't use this line. We are using this. But we need to have the extract interface. We need to provide extract interface based on here method number 2. We need to provide the extract contract interface in a parent contract. Okay? In a parent contract. So we still need to have an import. Under the child, we still need to have an import. We still need to have this particular child import. But over here, we will define the extract. Okay? How to define the extract? So, you put it as the extract. You define here. Extract. So you wanted them to access to your contract. Extract. Contract. Okay? You define as a contract. Maybe it's my interface for my child interface, okay? My child interface. You're going to say that Mitchell, why we need to use it? Okay? Why Mitchell wanted to explain for this one? Why I need to explain from here? Now, you imagine this is your parents. Your parents here got function. Your parents here got function A, function B, function C, A, B, C. So if you say that you go and create a child, you create a child A and child child B, you're using is parent, it means that your child A and child B can inherit all the function over here. You can inherit all the function over here. But now, however, maybe child A is only can inherit function. He only can call function A. And the child B can call function B and also function C. Okay? You control. You're going to control this child A and child B are different. You are not using its parents. You're not using this. If you're using its parents, means that all the functions inside the parents can be inherited to every child. Every child can access this. But in terms of controlling, certain function cannot be accessed by child A. So in this case, I'm going to define the interface. I'm going to define the interface for child A. I'm going to define the interface for child A. What can be accessed by child A? You go and define for the abstract. This is why we need to using the method 2 over here. The idea. Okay. Yes, sometimes you say that, we want everything make it simple. Child A, child B can be accessed all the function inside the parent, but may not. Okay? So that's why you go and define the abstract. Let's say inside these parents over here, I'm going to create another function just to stimulate that we have more than one functions over here. Okay, more than one function over here. Let's say I have a function. Okay, I have a function called MCO. Okay, for example, MCO, and then I also defining as an external. I purposely make it have more because I consider parents have more than one function. I need to demo for you. That's a more than one function, and this is an external. Is pure only. Pure is because I don't want. They do not go and modify. He do not read my state variable. Pure only. Okay, and he go and return. Make it simple. He going to return the string data. Okay, as I said, string data must be go and have a memory. Okay, so then over this side, I only go and return a very simple, return a message. Okay, okay, no more work from home. Okay, for example, so simple this like this. Okay, so I have this part over this side. Just wanted to tell you, inside the parents, I have more than one function. Okay, you assume set value is a function A, then this is another one. So now I'm going to have an interface that abstract child, abstract contract child, my child interface. From here, I'm going to define what function you can allow him to access. So for example, I want him to access for this one only. For example, I only want him to access this. So that's why I only need to copy the entire of the heading over here, paste it over here, but I will make it as virtual. This is a virtual. Okay, virtual. Okay, so this is the abstract. So you don't need to define what to be done. Okay, because this is the interface. What needs to be done at the MCO, MCO. Okay, for example. Okay, cannot think of any name. So that's why I just like this way defining the abstract from here. So by right, I have a set value and so on, but now I don't touch on this set value. So I only allow him to call this function, for example, for this. So in this case, what I need to do here is from the child over here, I still need to have this. I still need to have parents over here. I have no is parents already. I don't use this method already. So then over this side, I cannot get this value anymore because sum is controlling already. Because sum is an external based on the home there. Okay, you cannot access anymore already. They cannot identify where is your sum because you need control for that. So in this case, you wanted to go and call this function. Okay, you need to call this function. So now this one I make it as a comment. I make the entire of a comment over here. So I make it a block comment from this side. Okay. So now I'm going to call this function. Okay. Call MCO. Okay. So from here, so from this one I also make it as an external because you also can go and look for a call function. Okay. External view only. And because based on that, this now is a view only, I can have a return. Then I have a this string. Return string memory mark based on this, based on your parents over here. Am I right? You define. Okay? So from this one, I go to have a. You still need to create value. Where you referring to? This function you are calling from this interface. So where is your abstract interface? This my child interface. This name need to be used. My child interface is an abstract contract. You copy this my child interface from here and you put it over here. You call it my child interface from there. So this is, let's say it's a B lah, okay? I use the B as an example. So that I need to have my child interface. Then you need to have the address. Address of what? Address of your parents. Hold on. At this moment, your address of the parent you are not set yet. You are not set yet. You don't have the parent's address. You just have the address of the parent later on. So later on, I will have a return from B. You use the object, call what? Call your MCO. You can see, under the interface, you only can access MCO. You cannot call set value based on the interface you define over here. MCO only. You cannot call this function because under this interface you did not have any set value function over that. Okay. So now, what does mean a get address? I say that you are importing this does not mean that already successful. Okay. If you don't trust me, you can come to your error over here. He said that you are not able to find my child. You wanted to create instant the object of this be that under the parent over here. So that's why over here you are required to set address. How to set the address? From here, you need to have a function called set parent. Okay? Set parent address. Okay? So from here you need to passing in your address. Address of what? Address for your interface. Okay? Input. Okay? Input. I put it as a input contract address. So from here, external. Also, this one is also called by outside one. Okay? Not your contract for that. So then I will go and closing a bracket. So how you going to set this address? You're going to set from here, parent one. So then you need to define contract address over here. A bit messy, but have more control. So first of all, you go and input your parent.so file does not mean that you can directly refer already. So this is more control. You cannot directly refer to your all the functions from the parents based on here. So because you are creating using the interface, by using my child interface, you must know your parents' contract address. So by knowing how to set your parents' contract address, I need to have a function to set the parents' address, and then you need to pass in the contract, the input contract address of the parents over here. Then I will assign the input contract address as the parent address. Only then I can call. So from here, the logic here is you must be run your parents. You have the SO, you have this contract address, then only then you can set the contract. Only then you can call the MCO. Is it okay? Can get it? Or got error, anyone? If you have if problem, you let me know. I want you to understand the way. Can I? So you can have more control. Can anyone? So this is a concept of you need to define. Sometimes for the back end, we need to categorize what function can be accessed by child A, what function that can be accessed by child B. So that's why you are go and create an interface. For this example, I only demo for you that your parents over here only created my child interface. You assume this is my child interface A. I only allow child interface A to access MCO. Okay? And you make it as a virtual because the detail of this MCO function is defined over here already. So if you say that, okay, now I have a child B there, I allow child B to access function B and function C, then you create another abstract contract here. Get it now? So you create another abstract contract, my child interface B. Then you define what is the function that you allow for the child B to access. Okay? So from here, I only give you the idea. I created, you assume this is the child A function. Child A interface. The child A can access this function A only based on this diagram there. So now, moving on this, done. You can see that you compound, already compound, no error. Okay, remember after compound definitely you already have the file there. Then you have this particular child B, child over here. You assume this is a child A. Okay, you assume this is a child A. Okay, function. So now you set the address. So now what I need to do here is, first of all, I run my parents first. Okay, I go and import from a parent. So I delete everything here. No, not related already. Yeah. So now I'm going to run my parents. You can see over here the contract here called parents and child interface contract. Parents, so now I'm go and run from the parents first, because you are looking at the where I'm here. So this single inherit, I close it. Now you have a two file, parents and child. So I'm going to have a parent dot saw over here. I'm going to run compile already. So I'm going to run for my parent contract. Okay, I deploy. So over here I got the set value, also external, MCO also external. So no matter how, this is the external. Okay, so now even though they show you there, so you must know that it's an external. So now what I need to do here is I need this address. Okay, I need this address. If you don't have this address, I let you have a look under to this child there. I move back to the child. I go to the child there. I go to the child here now. I move to the child code. Then I come to the over this side. I go and deploy my child contract. Remember over here I only got child contract. Under the child.show here, I create, I deploy. Okay? So I already deployed from the child at the bottom here, and you can see that I'm call MCO. You have nothing. I cannot work. You cannot. Okay? You can see that. Cannot work for that. So let me go and see the debug code first. You can see that the error has been reworked. Okay, call the child, call MCO error. Virtual machine error that will revert. So the call function should be payable if actually it's not payable. It's not talking about payable because of the address problem. So cannot work because of missing the address. Even though you have the parents .show you imported, but cannot be worked. So that's why what I need to do over here is I need to come here, I need to copy the parents address. I copy the parents address, then I paste it onto I need to call set parents address first. Then I paste the function, I set the parents, I paste the address, I paste the contract address over here. After this, I go and set the parents address. After I set it already, so then I call. You can see that they can get it. Understand? So there is a different way of referring your parent and your child contract. Okay? You can create abstract. You can directly using method 1, import using is parent everything down in. Okay? Or you everything you lump sum and write in one source file and call. You have a caller can call the child and so on. So I hope you get some idea from here. Okay? Okay? I cannot decide to you what method you need to be used. It's based on your programming. Okay? Your way, you prefer one way. So now, as you can see just now, you saw cannot. anything got problem, cannot compile. Okay? I don't demo for you function B, function C, then I create another child B lah. It's the same, okay? Almost the same. It depends on your function, how you want to be applied for it. So now I'm coming to the function definition of the smart contract. As you can see, you have a function header. Just now you saw that. Then you have a function code. This one I don't write more already. Most of you understand. So under your, what I want you to bring in here is you have a parameter and return parameter, input parameter, then return parameter. So whatever the function that the variable that you created inside here is a local variable, so more specific name to be used. So under this one is telling you that you can have you can define your visibility modifier. Just now you did learn that we are using external. Okay, we use external as a visibility modifier. How others to visit to look at your function, and then we also got the access modifier. Access modifier is a view, pure, the kind of access modifier and return. So keyword and so on. Parameter, return parameter, usually we only mention the data type. So some of them you may want to mention the data type and identifier, almost the same. Now, remember this question over here. This one is an example. This is a front end. VAR is a front end. If you say that you are going to call it if you're going to call your back end got the function called get age gender. So and this get age gender based on your back end, you have a two return value. So it means that your front end must be make sure your JavaScript must be have a two variable over there are ready to receive a return data. Okay, so variable age, comma, gender. So that is a number of any number of value can be returned. Okay, when you return, as an example, you return two data at one time. So all the while just now we doing is we only return one value. Actually, you can return more than one value. Okay, you can return more than one value. So now, as I wanted to tell you, over here we don't have float, we don't have a double data type. Even though you saw the conversion from either convert it to the way or G way, we have a decimal value over there, but actually that is a conversion between way and G way that is not referred to the data type. Okay, we don't have a float, we don't have a float, we don't have a double data type like what you have in your front end C or Java. They don't have. So over here it said that under the Solidity support many type of basic types of high level language, we can have an unsigned integer. When you put unsigned integer is 256 bit, and integer, when you put integer, it means that you're allowed to have a positive and negative value, and the size of the size allocated for the integer and unsigned integer is 256 bit, means that it's 1 byte. Okay, 1 byte. 1 byte. 256 bit is 1 byte. No, 256 bit is not 1 byte. 1 byte is only 8 bits. Okay, 256 bit is how many bytes? 30. 16. Let me calculate. I forgot already. 256 divided by 8 bit, 32. 32 bytes. Divided by 30. Divided by 8 bits is 32 bytes. 128 divided by 8, 16 bit. So you can make it as this is a default already. So if you don't want to be so big, the size, instead of 256 bit, you can adjust it. You can define unsigned integer A, unsigned integer 128. You can mention about the bits that you wanted to have. So then we have a string boolean. And this sentence I wanted to tell you, even though you go and look for the solidity document, they say that they have a fixed point number just like a floating point, just like I said floating point cannot work. So that the fixed point number are not fully supported by the solidity yet. I use the word yet. They can be declared. You can declare the variable called float, but cannot assign them. They cannot store data from it. So they are not finalized to declare the fixed point number because they need to keep track the decimal point. So same thing is that, so single fixed point number where the MP, he defines, is that he have this one, you can define the size because it's a size of the n represent the number of bit taken by the card, that n represent the decimal point. So over here is wanted to tell you that even though he already have this data type, but it's not yet can be used. You can declare, you can say that fixed. You can make sure it's a fixed number. You can have this one data type fixed, okay, number, but still cannot be used one. You cannot assign over here, but cannot assign to or from that. You cannot give the value in that. No point. Okay? So under a version, when I check under the version 8.11, under the data type still cannot work under the solidity. So now you already understand state variable, local variable, then we have a global variable. So one of the global variable that you saw is a MSG dot sender. Okay? MSG dot sender, very common to be used to retrieve the account address. Special is that global variable is a special variable exit in a global namespace used to get about the blockchain. Okay, timestamp also. So this is a list of the global variable. These are the special variables which exist in the global workspace and provide information about the blockchain's transaction property. So what I wanted to tell you over here is they have many. I don't capture everything for you, but I just wanted to tell you we have using now, message value, msg.value. So you can go and look for transaction gas fee or gas price also. This is a gas price of the transaction. You can go. So then we have a msg.sender, just now I mentioned, address table. We will go to look for that. We will have using it. And then we are using the block timestamp. Okay? So if you wanted to look for the current block number, you can retrieve. And then you also can look for the block gas limit, this all. So, and the block difficulty you can retrieve. All these, we will use some of them, okay, in here, in this list. So, next week, we will come to using the address. Just now you saw I'm using the address data type, okay, to store the parent contract address. So then I will going to teach you address table and address. Okay. So then I will demo for you the address. Okay. So for this, your parent contract address that you have it. Those who are using our PC, laptop one, desktop one. So please go and download a copy of your code because we are going to use your parents and child smart contract to demo to using the address type to retrieve your owner or programmer address during a deploy. Okay, so we need to make it under the constructor then. Okay, you go and get a file first. So then we will go later on. We will going to have this basic data type. This one exercise number 2 can skip one. So then we have a pure and get. Then we will going to understand the differences between pure and get. Then we'll come to the array, push and pull, push and pop, array, then we will come to this exercise number 2. Okay? So this exercise actually can ignore what this is a basic data type. We go for this. So then we will go for the lab number 6. Any other question before I end of the class? Go and download your DAT3 contract if you are using by this week. I will go and upload one Google Doc, Google Sheet inside your Google Classroom there. So you're going to put in your assignment group member name there, so that I can see who are you, which one. You need to decide already. You need to decide which question you're going to do, and you need to further to look at your question, your assignment question. You need to brainstorming, start to brainstorming what kind of business rule need to be applied in your assignment for your problem statement.